this module, okay? And next week is going to be all review. We're doing all review next week, okay? But this, for today, we're doing multiplying 2-digit multiples of 10 by 2-digit numbers. So kind of like the warm-up problem we just did. But instead of the place value chart, we're using an area model, okay? So I did this problem yesterday. I'm just going to briefly review it, okay? So the problem is 30 times 25. So remember, I put 30 on one side, and I put 20 plus 5 on the other side, okay?
Good?
Oh, sure, yeah.
All right. So anyone who's wearing pants, can you stand up and show me your belt?
Hey, you guys show it.
You have a belt? What's your name? Christian.
Cool. Thanks, Ollie. All right, cool. Here we go. Refocusing in 5, 4, 3, 2, 1, 0. All right. All right, I got this here. Okay. If you have questions or concerns about your uniform, you can take it up with, 8th grade or Mr. Carroll or somebody. I don't specialize in uniforms. That's one I'm still learning. So, yeah, Lily.
Go to the bathroom. I have a bowl.
Sure, friend. Yeah. All right. So anyway, 30 times 25. Okay. So to review, I had 30 on one side, and then I split 25 up into expanded form, right? So 20 plus 5, which means that I can split this guy right down the middle. Okay. And it makes it much easier to multiply. So I can multiply. Remember, area is length times width. Okay. So length times width. 30 times 20, okay? Remember, we can multiply that really easily by multiplying 3 times 2 first, okay? Which is 6. And then 10 times 10, right? Because this is 3 tens, this is 2 tens. So 10 times 10 gives us 100, which means that this is 600, okay? Then over here, we have 30 times 5, right? Because opposite sides are the same. So if this is 30, that means this is 30, okay? So 30 times 5, remember I can do 3 times 5, which is 15. And then it's 3 tens times 5 ones. So 10 times 1 gives me 10. So it becomes 15 tens, or 150. Okay? And then since we're finding the area of the whole rectangle, we can just add together those pieces in the middle. Okay? And 600 plus 150 equals 750. Okay, so 30 times 25 is 750, which we just did that problem, right? Right before this. We just did that problem with the place value chart. So now you can you see the difference between what we did the other day and what we're doing today?
Yes.
Okay, Azul.
So technically, from the place value chart that we did earlier, we had the 15, and we didn't have two numbers in place value, so you had to get over to 600, but you just added them together.
Yeah. So yeah, I'm glad that you see that connection, right? So we did have 600s in our place value chart, right? Right before this. Well, I erased it, but we had 600s over here. And then we had 15 tens. I'm writing faster than I can count. Well, okay. Right? 600s, 15 tens. Can't have 2 digits in a place value, so that 10 has to bundle over. Okay, and adds to what we've already gotten there. So this becomes 7, maybe. Oh, that's a T. 7. And then this remains 5. Okay? And then 0 ones. So yeah, exactly, Isabel. So I like that you see the connection between those two. All right, any other questions about the area model?
No.
All right, cool. So here is the next part of this. Okay, so now that we've got the basics of the area model, okay, this is the next part and it's important. Okay, so remember again, you got to be paying attention. I don't want to repeat this in the future unless I have to. Okay, so 60 times 34 is what we were solving. Okay, could I also say 34 times 60?
Yeah.
Yeah. Is it the same problem?
Yeah.
Yes. Okay. All right. So again, one side is one of the digits. It doesn't matter which one. Okay, or not one of the digits. One of the numbers. The other one is the other side, right? 34 can be split up into 30 plus 4, right?
Yeah.
Class, what form is that in again?
Expanded.
Good, expanded form. Okay, 30 plus 4. Okay, which means that I could split that right down the middle, right? 30 plus 4, that gives me one section that is 60 by 30 and one section that is 60 by 4, right? And I can multiply those together and then add the partial products and get the final answer, okay? So this is the last one that I'll do by myself and then you guys will help me with the next one. Are we good?
Yeah.
Okay, so again, I can find the area of just this small rectangle, okay, by multiplying the length and the width, right? So what's the length, class? Go.
60.
60, good. So if the length is 60, what's the width, class? Go.
30.
30, good. So remember, I can multiply multiples of 10 together easily by multiplying the front numbers, okay? So 6 times 3. I know that 6 times 3 is 18, okay? And then remember, it's 6 tens times 3 tens. So I can do 10 times 10. What is 10 times 10? Go.
100.
100. So that makes this 1,800 or 1,800. Okay? Any questions on how I found that so far?
No.
Go ahead, Isabel. And then Abby.
Technically, you times 6 times 3 and you got 18, and then you added both the zeros, it's got you 1,800.
Yes. So the quick trick to explain this is 6 times 3, which is 18, and then throw in the 2 zeros, right? But remember yesterday and a little bit today I explained the why that works, right? Because if we were to write this in unit form, it would be 6 tens, right? This would be 3 tens. So after we multiply the 6 times the 3, then what's left is tens times tens. 10 times 10 is 100, so we would just kind of put it together, okay? Adler?
It makes sense now. Makes sense now because I thought you said addition and 6 plus 3 doesn't equal 18, but now.
Good, yeah, so we're multiplying, right? Because remember, it's called an area model because we're using the area formula, right? It's called an area model because we're using the area formula. So length times width, okay? All right, Kendall, then Lily, and then we're going to keep going.
So, how did you get 18,000 if 10 times 10 equals 100?
It's 1,800. That's 1,800, but we can also say 1,800, right? So 6 times 3 was 18, and then the 10 times 10 is 100, so it's just 1,800, okay? Go ahead, Lily.
So, when I work to the towards the time.
One more time, sorry.
So the 0 from the 30 and the 0 from the 60 came in, and that's our 2 zeros?
Yes. All right, good to move on?
Yeah.
Okay, so now I have to find the area of the next rectangle. Also, class, that was a great response. When I said, are you ready to move on? Everyone's like, yes. And I was like, great, okay. So, opposite sides are the same. So this is 60, that means this other side is what?
60.
60. I realize I didn't really outline that very well. Sorry. All right, anyway. So now to find the area of this rectangle, okay, this one right here, I got to do 60 times 4, okay? So again, I can multiply the 6 times the 4. That gives me 24, okay? And then this is 6 tens, and this is 4 ones. So 10 times 1 is 10, right? So that gives me 24 tens or 240, okay? All right. Everybody good on how we got that?
Yeah.
Beautiful. Thank you. Okay, good. Then, I'm going to teach you another vocab word. Are you ready?
Yeah.
Each of these are called partial products. I might have already told you about it, but partial products. Everybody say partial products.
Partial products.
Good. All right. So if I were to write out that word, partial products, okay, or that term, I guess, it's 2 words. Partial products. And as a heads up, I'm going to be using this vocab a lot, okay? I'm going to be using this term a lot. So partial products. Partial means part, right? Even the word part is in it. Partial means part. So does that mean whole?
No.
No, it's part, right? And then product is the answer to a multiplication problem, right? So partial products means it's part of the answer. We're almost to the answer, okay? So partial products come together to get the whole product, okay? Everybody get that?
Yes.
Okay, questions on partial products, because I'm going to be using that term a lot now. Lily?
We add the partial products together.
Yep, and we add the partial products together, that'll give us the whole product, okay? All right, so over here, well, in the directions it says find the product of 60 and 34 using an area model. That's what we just did. Record the partial products to solve. So what you guys will be doing on the homework, in order to work our way up to this, right? Some of you shared with me that your parents taught you how to do this already. If they did, no offense, parents, but please don't do it yet, okay? We need to know the why before we get there, okay? So if your parents taught you how to multiply with this, don't do it yet, okay? That's what we're going to get to on Monday, all right? So just hang on for one more day. But we're working our way up to this, so on the homework, you're going to actually record it. This is called the standard algorithm multiplication. We know how to do that already. We've just done it with smaller numbers, right? So we're going to record the partial products over here, okay? So let's see. Trying to think of the order here. Look, we're going to put, it doesn't totally matter the order, right? Because if I add 3 plus 2, I get 5, and if I add 2 plus 3, I still get 5, right? The order doesn't matter. But we record our partial products underneath and we add them together, okay? So 0 plus 0 is 0, 4 plus 0 is 4, 2 plus 8 is 10, 1 plus 1 is 2, okay? So our final product is 2040. All right, so on your homework, you're going to be doing the area model and then just writing the partial products under the standard algorithm. You're not solving the standard algorithm yet, you're just writing the partial products underneath, okay?
Yeah.
All right, Azul, then Lily, and then we're going to move on.
Why do you record them below the 34 times 60?
Yeah, so when we work our way to the standard algorithm, that's exactly what it's going to look like.
Okay.
So when you're solving with the standard algorithm, you'll have partial products underneath, okay? Lily?
I remember doing this in 3rd grade.
Oh, okay.
When we first learned area and perimeter.
Cool,
I
okay.
remember doing this and we recorded it underneath.
Awesome. Okay, then I hope it's familiar then. That's good. Austin.
Yeah, my mom, when she was showing me it, she's like this, and I was like, what?
Mm-hmm.
She was like, this is how you're going to do it later, and then
Yeah.
later in your life.
Yeah. And later being like early next week. So yeah, we just gotta wait a little longer, okay? Jenny, go ahead. All right, any other questions on this problem?
No.
Are you ready to try one?
Yes.
Okay, and then I lied, I'm sorry, won't have time to do homework in class today, okay? But we will be able to do one of these problems together. Can we do, yeah, go ahead and go to the blank side of your whiteboard. We're gonna do this one. Okay? You're fine. You're fine. Blank side of your whiteboard, go ahead and just write this, just like this. Write it 90 times 34, somewhere on your board, but leave space for an area model, okay? Nola?
Is it okay if I do it on my notebook? So
That's fine.
when I do my
Yes, that is fine. Yeah, Lily?
Would area model be long ways or this one?
Does not matter, as long as it's a rectangle. Which I should make mine more of a rectangle, less of a square. Actually.
That's a weird line.
better.
Yeah. Marker.
All right, here we go. I'm starting in 5, 4, 3, 2, 1. Here we go. All right. We're going to first label our area model. If you have a distraction of some sort, I would put that away just so that way we're all on the same page. Here we go. 90 times 34. Okay? So 90 times 34. It makes more sense to put the bigger number on the bigger side. Do you agree?
Yes.
Do you technically have to do that?
No.
No. But, I mean, might as well, right? So, I'm going to put 90 up here, but if your rectangle looks different, go ahead and do it differently. That's okay with me, okay? So, on the other side, we've got to put 34. Someone raise your hand. Tell me how you would split up 34 into expanded form. Elizabeth, go.
30 plus 4.
30 plus 4. Amen, sister. 30 plus 4. Okay? Go ahead and do that on your other side. So you should have 90 on one side, and then 34 in expanded form on the other side. Yeah, Lily.
So, on our last problem, we put the, 30 plus 4 on top. How do we know to put it on the top or the side?
It does not matter.
Okay.
Any side that you put it on, you're still going to get the same answer. Okay? As long as you set it up correctly as far as numbers go. But I personally put the 90 up here, also to show you that it doesn't matter what side you put it on. But 90 is bigger, and this is a longer side, so that's the only reason I put it. But all right. Okay. Someone raise your hand. Tell me what I do next. Nola, go ahead.
Times 9. Do 9 times 3.
You're close. There's one thing we have to do before that.
Oh, 9 times 4.
Mm-mm. Something I gotta add to my drawing, my thing. Yeah, Daphne?
Put a line through the middle.
Yeah. This way?
No.
Which way?
Horizontal.
Yeah, horizontal. Why, Daphne?
So it separates 90 from 30 and 90.
Good. Yeah, it makes my two parts of my area model, right? So 90 times 30 and then 90 times 4. Okay, Nola, back to you. What do I do next?
You times 9 times 3.
Good. 9 times 3. You got 9 times 3? Go, yeah, go for it. You can do it. 27. Good. Okay, everybody out there with me so far?
Yes.
So Nola did 9 times 3 and got 27. Okay, now, remember, we're working with 9 tens and 3 tens that we're multiplying together. So we just multiplied the 9 times the 3, so what's left is 10 times 10, okay? Class, what's 10 times 10?
100.
100. So this makes this what?
270.
Close.
2,700.
Good, or 2,700, okay? All right, quickly, here we go. Class, think about it. 9 times 4, don't say it. Think about it. 9 times 4, you can do it. Ready? Go.
36.
36, and then we throw on that 0 because we're doing 10 times 1, right? Okay, really quickly, here we go. 2,700 plus 360. Solve it, go.
3,060.
No talking. I'm thinking, sorry. Nope, yep. Okay. Okay, what'd you get?
3,060.
All right, I believe you. Good. Okay, good job. I'm going to give you your homework on the way out.